In this video, I'm going to build this report page, which has 4 visuals. There is a Azure map visual, there is a ArcGIS map visual, and there is a relative date slicer on the top left, and there is also a bar chart. I'm going to use USGS earthquakes data, and I'm trying to build this report page by understanding a few concepts like a ring of fire, latitude and longitudes, and then I will try to create a couple of calculated columns and build that report page. This is what I'm trying to build, a ring of fire as shown here. It's where the 90% of world's volcanic activity or earthquakes happen in that particular belt. In the previous videos, I've used the same data set and I've created those pages as highlighted here. So first and foremost, let me take you to the table view and show you the data. This is the data: time, latitude, longitude, magnitude, etc. And also, I have loaded this data by using a web connector, and the data is updated every minute. And I did a few transformations in Power Query. As shown here, I've created a couple of calculated columns as well. So pretty simple data and easy to work with. And I have done some transformations, like I said, in Power Query. And if you haven't watched, please watch those previous videos so that you'll understand the data better. And I have created these calculated columns. So what I have done is, as shown here, I can show you the link. I will leave this link in the description box below. This is the USGS earthquakes data, and I have used the get data, and by using web connector, I have pulled in the data and did some transformations. And periodically, I can refresh the data here in Power BI Desktop. And subsequently, once I publish in Power BI Service, I can do all those scheduled refresh as well. And this is the data as shown here. These are the various fields and time, longitude, latitude, depth, magnitude, etc. And this data is updated every minute as shown on the right hand side. We have those different days. It is updated past day, past 7 days, past 30 days. So I've used that past 30 days data and used the web connector to pull in the data. And let us try to understand a couple of concepts. And before that, let me also show you what I've done in the previous videos. This is the dashboard I have built in one of the videos. And I've done the magnitude and energy analysis. We have created a few measures and calculated columns and tooltip, zoom slider. And also I've created another page, real-time seismic activity tracking. And also I've used this data to show you info functions. And in this video, I'm trying to create a ring of fire, as we have already seen. And this is the data. And let us try to understand a few concepts before we jump into creating the calculated column. So as a first step, let me type in ring of fire in Google search box. And ring of fire is a horseshoe-shaped zone around the Pacific Ocean, known for intense volcanic and seismic activity, and it's home to 75% of Earth's volcanoes and 90% of its Earth activities. And I am trying to map the data points in that particular shape, right? That is what I'm trying to do. I'll create a calculated column, name it as ring of fire, and I'll try to plot all the data points, whether they're appearing in that particular belt or not. I want to just find out. So this video will help you to kind of understand the logic, what we are trying to build, and then try to build those report pages by creating some calculated columns. This is the belt, what I was talking about, ring of fire. This is kind of horseshoe shape, and we are trying to grab the latitude and longitude values from our data and try to build this report page. And latitude and longitude are a global grid system of imaginary lines used to pinpoint any location on Earth. And latitudes are also called as parallels. They measure position north or south of the equator. And these lines run horizontally east to west, and from 0 degrees to 90 degrees north or 90 degrees south. And longitudes are also called as meridians, and these measure position east or west of the prime meridian, which is 0 degrees. And these lines run vertically north and south. And let me just try to click on this picture. These are the latitude lines and these are the longitude lines. So now that we have understood this concept, like I was saying, let us try to use the latitude and longitude values from our data set. And this data set is periodically updated every minute or so. We will try to use the manual refresh in Power BI Desktop and try to bring the data so that we have the latest data in our Power BI Desktop. And I did some research online on how to define the zone for the ring of fire belt. And in the earthquakes data, there are latitude and longitude columns as shown. And using those values, one could create a calculated column and use it in Azure Map or any other visual. So let me try to create a new calculated column. And I think there could be better methods to define that zone, but this is what I've come up with. I will create a calculated column, and the name is ring of fire. And ring of fire is equal to, what I could do is first I will define two local variables. And by using keyword var, I will capture the latitude and longitude values for the current row in the earthquakes table. And by creating these two variables, it makes sense for us that the subsequent logic will be easier to read and improves performance, right? So by referencing the data only once, that is the reason why I've created these two variables, variable lat and variable long. And in return, what I could do is I can add the coordinate bounding boxes logic in the switch function. To save time, I have pasted the complete code here. As you can see, it's a bit long but easy to understand. I captured those two variables there. And the western arc targets the coastlines of New Zealand, the Philippines, and Japan. It captures latitudes from the southern hemisphere, -50, etc., as shown here. And the northern arc acts as a bridge across the North Pacific. It looks for higher latitudes and uses an OR statement to bridge the international date line. This is pretty important. And longitudes greater than 160 or less than -130. And also we have this North American arc, and it isolates the west coast, Cascades, and California by using a very narrow longitude window, -130 to -15. We are ensuring that tremors in the central or eastern United States are excluded because we are trying to kind of understand the zone and try to plot the earthquakes in that particular region. So we are trying to do this by dividing everything into 4 different distinct zones. There is South America, and South America hugs the Andes mountain range by filtering for the western edge of the continent. That is longitudes -85 to -65. And you can pause the code and try to understand the logic here. Like I said, we are dividing everything into 4: western arc, northern arc, North American arc, and South American arc, so that it will be easy for us to plot these data points in our map visuals. And this code block identifies earthquakes within the ring of fire by defining 4 specific geographic bounding boxes using latitude and longitude. And we are using a switch function to check if an earthquake's coordinates fall within the coastal boundaries of these 4 arcs that we have defined. So it's pretty simple to understand once you understand the logic. And the switch true function acts as a collection of if-then statements. So it evaluates each block of logic in order. As soon as a coordinate pair satisfies a condition, it returns the value ring of fire. If none of the conditions are met, it returns the default value outside. So thereby I'm hoping that there could be better methods too, but I'm hoping that we should be able to grab all those different zones, western arc, northern arc, North American arc, etc. And as we have applied regional geographic filters, the code segments the Pacific basin into 4 distinct arcs based on coordinate bounding boxes, like we have seen: western arc, northern arc, North American arc, and South American arc. So this way we will try to get those 2 buckets of data points. One, if it is in the ring of fire, we'll get those points. Anything outside this particular 4 segments, it will go into the outside bucket. So this should be easy for us to understand. And now that the calculated column is ready, and as you can see, the result of this code captures the number of earthquakes that fall into 2 segments, ring of fire or outside. So we can use this for path ID in Azure Maps visual. So that is the whole idea. That is the reason why we are creating this calculated column. And once this is ready, we could use that for path ID in Azure Maps or any other visual. And also we could use it for the bar chart as well. So take a moment, pause the video and look at the code, and it's pretty easy to understand. I've approximated all the values here. I'm sure there could be improvements to this code as well. So we can use this as a field in any of the map visuals, Azure map or ArcGIS map, and then maybe use a visual level filter on it to capture only matching values for ring of fire. So that is the ultimate goal. So let me try to commit to this code. Once I commit, I have my calculated column ready. I think maybe I will try to create another column later on, but for now, let me just create this column. So as a first step in the report page, let me try to drag Azure map visual, click on it. Once I click on it, I have my visual ready. So as you can see, there are various things you can pass to this visual: location, latitude, longitude, legend, size, tooltips, path ID, and point order. So for now, we'll try to keep it simple. There are many tutorials which will teach you how to work on this Azure maps. But in our case, we are trying to pass a couple of fields to this visual, and we'll try to make it simple. So I will add latitude to latitude, and I'll drag longitude to the longitude field. So that way we have those two things. As soon as I do that, there is no surprise. We have all those data points from our data set. Those are being shown on the map visual. So this is the first step. So we can tweak the way in which this Azure map looks. You can change the grayscale from light to hybrid to satellite and all those things. Based on your needs, you can do all those things. But for now, let me just try to keep it simple. Like I said, you can add many more things here. If you have a location, if you have any other metric you want to add it to the size for this visual, you can do that. But for now, I've just used latitude and longitude, and we have just created the calculated column ring of fire. So probably I can drag that column here to the path ID. So that way we have a path layer, and since all these events are happening at different points of time and different locations in the world, by using the path ID, let me try to kind of connect all these points, and there is a line which is formed between these points. So adding this path ID layer will help us to achieve that. Like I said, you can do all the changes here from grayscale to hybrid. You can add all those other things too, but in this case, let me just try to maybe drag the path ID to the path ID field in the Azure map visual. So let me just do that. Let me just go ahead and try to close this, and let me just try to select that ring of fire calculated column which we have created. So that way, like I was saying, you can connect all those data points, and let us see what happens once we do that. Let me click on path ID here. Let me choose ring of fire, the calculated column which I have just created. Once I add that here, as you can see, yes, the lines are formed. But as you see these zigzag lines, that is probably because earthquake events happen in a non-sequential pattern. A earthquake can happen in one area, and next earthquake could be somewhere other area. So this visual can be improved, right? So what we could do is, by using maybe adding any other path ID, we need to find a way to create one-dimensional sort key, right? Path ID is not helping us, not much. So there is another thing which we can add, which is called as order. So we need a sorting column. So what I could do is, maybe I will create a calculated column, and after it is ready, we can use this in Azure map as point order. That way we have some kind of a sort, so that will be helpful for us to maybe minimize these zigzag lines. So I will create a calculated column, new column. I can create this column, and to save time, what I will do is I will paste the code here. That way it will be helpful for us to go step by step and try to understand the code. Here is the code, and after capturing the values in the two variables like we did in the previous calculated column, we are normalizing the longitude. As you see, var adjusted lon. And why do we need to do this step is that it prevents a break at the international date line. By adding 360 to negative values, the Western Hemisphere, the Americas now follow Asia and Oceania in a continuous numerical sequence moving east. That is the reason we do that. And why are we trying to divide latitude by 1000. This formula divides latitude by 1000 to turn it into a decimal tiebreaker. Since longitude is a whole number, adding latitude by 1000 will ensure that the longitude determines the primary position in the list, and the latitude only shifts the order. And another rule B is for the Americas. If longitude less than 0, adjusted longitude minus latitude by 1000. The logic is for the Western Hemisphere, it uses the adjusted longitude, which is now between 180 and 360, and subtracts a tiny fraction of the latitude. That is what I have done. Yeah, it's a little bit complicated code to understand, but the logic is by doing this, we get the result, right? The earthquakes are sorted west to east. Because latitude is subtracted for the same longitude, the sort will go from north to south in decreasing values. That's the reason why this is helpful. And the default is adjusted lon. Now that I have done this part, I can commit the code. If I commit the code, then I have this calculated column that I could use for point order. So let me just commit to the code. The calculated column is ready. And for you to understand a bit more, and this is a summary table. We have the region, Asia, Oceania, America, Southern, and we have the longitude range and latitude sort direction. You can pause the video and probably look at the code a bit closely. Like I said, I am not an expert in these kind of things as far as maps are concerned. So maybe there are better methods, but for now, I have just come up with this method. If I drag that onto point order, as you can see, there could be a little bit changes here, and we can still see the zigzag pattern, right? But most of the things will be minimized. And one way to fix is to use a visual level filter and capture values that only match ring of fire, and also use a relative date slicer so that the data points are not cluttered. As you can see, there are many points here. So I can add this field to the Azure Visual Point as a point order, and we are still seeing the zigzag pattern, right? So we can minimize it, and like I said, events happen in different times and different time zones and also different locations. And what I've done is I've dragged the date field here as a slicer, and by selecting that visual, what I could do is I can go to format pane and I can change it to relative date or time. Since this is the date, I will use relative date. There is a timestamp, I can use that as well, but for now I will use this relative date. And for the values, I can add an anchor date, or I can make all the selections by using the toggle, whether I want to include today or not. I can switch that off. And in case if your data needs an anchor date, you can always add the anchor date, so that by using the relative date slicer, you can look back a few of those things, right? For example, last 1 month, last 1 day, etc., as shown here, and last 1 week, 10 weeks, or whatever. And like I was saying earlier, you can change the way your Azure map looks. You can change it to hybrid. So now we have data points appearing here. For example, as we have seen earlier, ring of fire, that is kind of a horseshoe shaped belt in Pacific Ocean. So that we have those points also here, but we have points which are shown up here, which are outside the range also, right? So we can fix that by using a visual level filter. So we can do that. That way we capture only the events which are happening in the ring of fire. So what I have done is I've gone ahead using the filter. I have selected only ring of fire. So now the map visual looks a little bit better as shown here. You can see this is almost the similar ring of fire which was there when we have read about what is ring of fire. So those data points are there. So I can keep adding more fields here. For the tooltips, I can add a few more so that if somebody hovers over these data points, they can see those things, right? For example, I can add the timestamp here so that when you hover over any kind of data point, you can see the time. Maybe you can see the magnitude, depth, or whatever. Basically, whatever you want to add here, you can add. For example, I'm adding the place. So we want to know where it happened, when it happened, and maybe if you want, you can add magnitude, etc. So whenever I make selections on the relative date slicer, the values are changed. For example, last 1 day, those values are changing. So this is so far so good, right? So we don't have to create anything complicated, but trying to understand where the ring of fire zone lies, we tried to use latitude and longitude and created the ring of fire. This is the final report page, which I have already created. I will show you step by step what I have done there. So this is the relative date slicer. I've added the date column there, and I've used the anchor date in case if I want, I could have used, but I did not use. And this is a pretty simple thing. I've done some formatting, color, background, etc. And this is the relative date slicer, and this is the bar chart as shown here. These are the values for y-axis ring of fire, for x-axis the total earthquakes, the number of records in our table, that is total earthquakes measure. And I have done some formatting, like I was saying. I have added this conditional formatting. So that way we have different colors. When it is matching ring of fire, we have one color. When it is outside, it's a different color. So that way user will be able to see as soon as they make selections on the relative date slicer, they can see the bar chart. What are the total earthquakes which are matching ring of fire, and what are the earthquakes which are outside this ring of fire. So I have done all those small format settings. Based on your needs, you can change. And again, this is the ArcGIS map. I have changed it to hybrid, for example. That way you have some boundaries in the map, and as shown here you can see those labels as well popping up. And these are the various fields which I've added: the latitude, longitude, and tooltips, place and time, and path ID is ring of fire, and the point order is the calculated column which we have created, the second one. And this is ArcGIS map, and as shown here, these are the various values, latitude and longitude. And we have added tooltips, all the other four things: place, ring of fire, magnitude, depth, and depth category. And that way if you hover over any point, you can see them. And also, if you can see in ArcGIS map, there is a shape for the ring of fire, right? We could do that by trying to go to this place. For example, if I hover over any point, I can see all those metrics. If I click on those three lines there, and I can make this changes to the settings, I can add any other layers here. What I'm trying to do is I want to add another layer. That's what I did. I went and clicked on this particular button, and you see already there is something called as Pacific ring of fire. So by clicking on the ArcGIS, I can add this layer. All I have to do is search for whatever layer I want to add. I have searched for Pacific ring of fire. Once I search for it, and I have that particular thing showed up, that item, and I've selected that and added that as a layer. That's how you can see that shape in ArcGIS map. So that was not available in Azure Maps, but this is helpful for us. So we could easily add any kind of layers. In case if you want to add any demographics also, we can add. So now we can see that we have already used the visual level filter like we did for Azure map. So you have all those data points which are appearing in both the maps, right? This is cool, and I have refreshed the data. Once I refresh and look back, say for the example last 1 month or last one day, for example, let me check last one day, I can see that all those points are changing, right? This is pretty cool. In a short time, we have understood the logic, and we have understood that we could always plot. This is not the best of the best. I'm sure there are a lot of other methods which will improve upon what I did, but my attempt was to try to see if the earthquakes are happening in those different four arcs what we have defined earlier for a ring of fire. And looks like most of the earthquakes are happening, 75 to 90% of the earthquakes, when we are using the relative date slicer, whether it is last one day or last 1 month or 1 week, we can see that the maximum earthquakes are happening in ring of fire. So this is cool, and in a short time we have done a good job, I feel. And this way we have the data coming in, and we can refresh the data, and periodically we can check to see if whatever research has been done for so many years, and they say that all those points fall into most of the earthquakes happen in this specific ring of time fire. So that is been proven. So this is pretty cool. Thanks for watching. See you in the next video.